Good afternoon. Thank you so much for coming. I'm glad you all chose to come to see my little session today. I see a few familiar faces, so I guess I didn't scare you all off yesterday. I don't mind admitting that I've been a little bit jealous of my friends in the tools area because they have these snazzy demos they get to do, and I work on the CLR and I work on performance, and it's kind of hard to demonstrate working set and stuff. It doesn't have colors and IntelliSense and completion and stuff. But today I get my revenge because this, ladies and gentlemen, is the MacGyver session. Okay? This is where I'm going to show you how to find what ails you using nothing but a piece of bubble gum, 12 inches of string, and a pencil. Okay? Now, okay, it's not, I lied already. It's not really a pencil, but it's simple stuff you can download in about 5 minutes from anywhere, and you can try it on any computer. So wherever you have your problem, you can do this. Now, this is important for someone in my line of work because when I break the CLR, not that I've ever done that or anything, but if the CLR were to be broken on some day and we needed to kind of find problems or performance issues, we need to be able to do it with comparatively low-level tools when we've kind of made it so the IDE couldn't possibly work. So we have quite a bit of experience with this low-level stuff. Now, I'd like to demonstrate it for you all. I'd be doing a demo, but they only gave me 45 minutes today. And so in the interest of speed, I've kind of taken screenshots of the interesting stuff all the way along. And if there's any justice in the world, I'll do a video and get the Channel 9 guys to maybe post me doing this all stuff live so you can see it. All the tools I'm going to show you today, you can find pointers to them all on my blog. So please go and look at my blog afterwards, and there's more detailed explanation of some of this stuff. But I'm just going to walk you through what I do when I'm doing a performance investigation, especially looking for memory problems. Okay? So on that note, let's get started. All right. The thing about memory problems, and that's what we're here to discuss today, is they come in many different flavors. So it's hard to say, what should you do, right? I mean, you could have a code problem, you could have a data problem, you could have jitting problem, you could have rebasing problem, you could have who knows what kind of problem you have. So I always start by looking at what's going on and trying to account for all the memory that my process is using and seeing where that problem is. And depending on where I start seeing large amounts of memory, especially unexpected large amounts of memory, that will guide me as to what tools I should use kind of in my continuing analysis, right? And we do have a lot of tools available. Now, you're not always going to want to use this bubble gum that I'm going to give you because there's some good stuff that's available from our friends in Visual Studio Team Services. The VSTS profiler's got some great features, and you'll want to use some of those, and you'll want to use some of the graphical tools that provide visual equivalents. But it's nice to know that in less than 5 minutes, you could have all this stuff going and do an analysis. So let's see where we get started. All right. First, I start by using VA dump. Raise your hand if you know what VA dump is. Okay, like 3 people, 4 people know what VA dump is maybe? Okay, not that many people. VA dump stands for virtual address dump. It's a very small executable, and it's one of my best friends. You can download it from Microsoft websites. Again, the link's on my blog. And it gives you a summary of the working set of a given process. Now, in this particular case, on the other slides, I'll try to show the command line, but for space reasons, I didn't even show the command line here. But all I typed at the console was VA dump-SOP, and I gave the process ID of the process that I was interested in, and that instructs it to give a summary of a particular process. So I got this. VA dump will actually dump every page and what state it's in and give a massively long report. But generally, the summary is what you want, so that's what I asked for. Now, what does this all mean? Look at the report from the bottom. Okay? If you look at the report from the bottom, you'll see, looking at the bottom 3 columns there, under private, there are about 2 megabytes of private pages and 6 megabytes, well, 5.6 megabytes of shareable pages and 2.5 megabytes of shared pages. So remember yesterday I was talking about the difference between private and shareable pages. We like shared pages. We don't like private pages nearly so much. So this is giving us an idea of overall how much memory is this process using, right? In kilobytes, the whole thing is about 10 meg with that breakdown. And you can see that right down at the very bottom. VA dump tends to think in pages, so many of the numbers are stated in pages like in that first column. But the difference between a page and kilobytes is just multiplying by 4K, as you can see. All right, reading up, you can see that of that 10 meg, about 200K was system, about 1.7 meg was dynamic data, and about 8.4 meg was modules. That's code, okay? So, which brings us to the next point. Okay, in addition to the summary that you just saw, you get these lines as part of the same output. This is like what came right after on the next screen full. And I've edited this just a tiny bit to format it up nicely here. But you can see that the different modules that were loaded into this executable are listed here. And you can, and without me even telling you, you can see right at the top, I was actually doing this experiment on CLR Profiler itself, okay, which is a nice little managed app I happen to have lying around. And it was a mere 39 pages. So multiply that by 4. What's that? 80K? 80K for the XE. And then looking down, you can see there was a good chunk of code loaded for MS CoreWorks, most of which was, very few of which were private, right? You can see most of it was shareable. That's good, because if there's multiple managed applications running, then you're going to get nice results from MS CoreWorks. Very little of that has to be duplicated. So your second and third process is going to be very cheap. Similarly for MSVCR 8.0. And looking down at the next one, you'll see mscorelib.ni.dll. That's my baby. Well, not just my baby, but that's what I work on the most. Our BCL classes are right there. And it's the first managed module you'll see. And yesterday I was telling you that because of things we did in InGen, we got the number of private pages way down in some of our modules, right? And in fact, if you look at that one, you'll see that result right there, because there are only 16 thin little private pages associated with mscorelib.ni of a total of 355. That's a really good number, right? That's well less than 10%. And we were aiming for, you know, we were aiming for around 10%, but hoping to always less is better. Now, again, just looking at these guys, okay, you can tell some stuff, whether you're starting to have problems, right? You can look and see, well, how many assemblies are there? Do I have a code problem? Do I have too many assemblies? You know, maybe I could defer load some of those assemblies. A lot of code is a common problem. So looking at your scenarios and seeing how much is resident from this summary will give you a big tip. If the number of private pages that's associated with a particular DLL, like mscorelib.ni.dll, for instance, if that private page number was to be very close to the total, that's a sure sign that that DLL has been rebased. Okay? DLLs not getting their preferred load address is bad news for your performance and bad news for memory overall on the system. So if you were seeing rebased DLLs, you'd want to go and look at NGenning again with different base addresses and making sure that your DLLs were getting striped. Sometimes, for instance, people have 20, 30, 40 DLLs, and with no base address specified, they all get the default. Well, guess what? Only one of them can win. All the rest will be fully relocated, and all those benefits we gave you with work in NGen will go right down the tube. So make sure that you're seeing the kind of private page numbers that you want to see. You want to see those numbers down around 10% for the .ni files, okay? And in this version of the system, the native images, that is the NGen versions of our DLLs, have .ni in the name, so they're very easy to spot. In previous versions, they had the very same name as the other ones, so you couldn't tell by the base name. You had to go and find where the module was coming from, and you'd see this big long path that's very embarrassing. So now it's very simple, .ni right in your face. Okay, so looking at the module list, you can already tell. Do I have a code problem? Should I be thinking about sharing? Should I be thinking about NGen? What could I be doing there? Okay? Let's move on. Back on that other slide, there was one significant row that you may have noticed or may not have noticed. You can check the slides later. Other data. What the heck is other data? Well, VA dump breaks the data down into segments that it understands. And it knows about Windows structure. So it knows about things like stacks. And it knows about things like the Windows heap. And it knows about page tables and system structures and so forth. And it categorizes those. But sometimes you have other stuff. Stuff that it doesn't understand. And a classic example of stuff it doesn't understand is pretty much everything that we do. The garbage collected heap is other data as far as VA dump is concerned, because it doesn't understand the structure of the garbage collected heap. And our loader heaps, where we keep class information and, you know, information about what assemblies are loaded and linkage and binding and so forth, those are also things that it doesn't especially understand. So if you see large amounts of other data, you need to drill down on that to see, well, what is that other data? Is that managed data? It could be as simple as a bitmap. It might be that you've just got a big bitmap in your program, and a big bitmap would look like other data to VA dump as well. But it could be the CLR, okay? And if there's issues, if there's space issues that you're having, well, we want to drill into those. So how do we do that? Well, the first thing we're going to want to do is attach to the process in question with a debugger like WinDBG, okay? Now, let me ask another question. How many of you are familiar with WinDBG? Okay, lots of people familiar with WinDBG. That's great. WinDBG is our sort of SDK debugger, and you can download it. You can get it on any machine. It installs in like 2 minutes flat. It's nowhere near as rich and, doesn't have the powerful GUI of the IDE, but it has some very cool command line features, and you can get it anywhere, anytime, and that's a really super valuable feature. You can use it to make dumps and so forth. So sometimes we pull that out. So what I've done here is, before this command that I typed, I first typed WinDBG-P and the process ID of the thing I wanted to attach to, and I got a command line prompt, and I entered that first little command there. You can see .load by SOS MS CoreWorks. Okay? SOS is our extension that can dump internal CLR structures. Okay? And it has a variety of different commands. This particular command, .load by SOS MS CoreWorks, means go and look at where MS CoreWorks was loaded from. That's our main kernel, if you will. Okay? And in that same place, see if you can find a DLL named SOS. And if there is one, load it. That's a debugger extension. Now, what's great about that command is no matter what version of the runtime you've got, if there is an SOS, no matter where it came from, you're going to get the right SOS, the one that matches MS CoreWorks. So that's a little debugger trickery. And that's pretty much what I always type. So type that, and then I have the power to type the next command, !EE-heap. Okay? EE-heap will dump a bunch of interesting statistics about what we know is going on in the runtime at this very instant. It's more accurate than the performance counters, for instance, which are only updated when a garbage collect happens. It's what's going on now, now, now. And it includes stuff that's on the heap, whether it's alive or dead, right? So sometimes it's interesting, for instance, to force a garbage collect immediately before you do this, so you're only looking at live objects. But for this analysis, I just went ahead and dumped what there was. Okay, so here we are. Bang, EE-heap, great. And what do we see? We see among the lines, and I've skipped some so it fits on the slide, but one of the lines will be right here where it talks about how big the JIT code heap is. Okay, and usually that's the one that I call out. In this case, there's 16K of JITted code. Okay, and that's because the CLR profiler executable that I ran was not engined. Okay, so we needed to JIT the exe, and as you'll recall from that first slide, the exe is not too big, so the IL for that had to be loaded was comparatively modest. What you were seeing there was an IL module loaded. So in addition to the cost of the IL, there's the cost of the JITted code sitting on loader heaps. And here it is, right here, 16K of it. In addition to that 16K, there's a bunch of information about loaded types and dependencies and other things that we put on the loader heap. And you can see that our sort of class overhead for this particular executable, the total was 217K, okay, of which the 16K was part of that, right? So you can see the bulk of it, that 200K, is actually, loaded method tables and other kinds of internal data structures that we use. Those guys all sit on loader heaps, and so you can see kind of what the charge is for all the types that you're loading. So if you were seeing huge amounts of data in loader heaps, that would be indicative of having, a vast forest of types. If you had many, many types and they were all loaded and none of them were being JITted, I'm sorry, if they were all being JITted, that would increase the cost in the loader heap, even if the code was fairly modest. Some of the cost that's normally going into the loader heap, things like method tables and so forth, if you pre-JIT, those structures are persistent in the image. So rather than having to allocate dynamic memory for them, they're just loaded right along with the image, and we can refer to them in place in the image. So that's good for you because those are shared pages, right? So they can be shared across your executables. If they're here, they can't be. All right? So if you're seeing huge amounts of loaded heap, again, you might want to consider engineering as a solution to help get those down. You might want to think about ways to cull the number of assemblies that you're loading in a particular scenario, or do deferring. Sometimes in startup scenarios, all you really need to do, for instance, is move the loads from a time where it's not appropriate and you can't afford it to a time where it's reasonable to load it. And there's many techniques that you can use to defer loading. So this could be a tip that, hey, you need to think about, total modules, total types being loaded. The last number here is the total size of the garbage collected heap. There were, in fact, intermediate lines, I elided them here, that showed the various different garbage collector segments and how big each generation was. So you can get those statistics as well from this same command. But the total GC heap size here is 687K. All right? So you can then see, looking at this, well, am I looking at a JITted code problem? Am I looking at too many types loaded? Am I looking at a GC heap problem? Is the problem that my GC heap is too big? So this neatly breaks out your other data, okay? Because all of this is a piece of the other data that you saw. And in fact, this is the managed component. So if there's other data beyond this amount, the sum of these two, the GC heap and plus the loader heaps, that is most likely things like a sound clip, a bitmap, or lots of bitmaps, or other kinds of unmanaged resources that got allocated by a system. And you can run those down too if you need to. But now you're not looking at a managed code problem. All right, moving swiftly along. Okay, suppose it is the GC heap. Say the GC heap is too big, and you want to know what's going on. Okay, well, it turns out we have got a command for that. Exclamation point, dump heap dash stat. That's the hospital command, right? Dump heap stat. Okay, so I want to go and see what's on there and get rough statistics for what the different types are. This is showing the bottom of that report. It actually went on for a couple of pages because there were lots of loaded types. But it turns out that it sorts them in increasing cost. So the biggest cost things are at the bottom, which is great because that means you never have to scroll up. You just let it run, and what you see at the bottom is what you really need to see. So you can see in this particular example, what's on the heap is there's a bunch of hash table enumerators. Probably most of those are dead at the moment, and they would just they would go away if I collected, because hash table enumerators don't tend to live so long. So they're probably not very exciting. There's a bunch of strings, okay, and maybe some of those are pretty exciting. So actually, we'll talk about those in a moment. And there's a bunch of hash tables, okay, and they're adding up to about 8K, and there's 28K of object arrays. So it might be more interesting in this example if I forced a collect first, and then I could see what's really live that I care about. But in other cases, you know, you need to see overall what's live. And, you know, so for purposes of this discussion, dump heap dash stat will give you the information you need to tell you what's on the heap at any given moment. You can see how much dead stuff there is and live stuff there is by comparison, and see how effective the collector is being for you. Okay? Now, again, output is sorted. What you see at the bottom is probably what you're going to look at. And string is often down there, which brings us to the next exciting command. This is new in Whitby. It's a little gem I added myself, actually. Dump heap dash strings will tell you what strings are on the heap and give you the first, 70-odd characters of them, so that you can get a feel for what the heck are these strings. A lot of times you'll find that, look in this example, this is a very popular situation. There are 49 copies of the string Microsoft Sans Serif on the heap at this exact moment. Okay, and well, it's a WinForms application, okay, and it turns out that font string has been copied a bunch of times. That's maybe indicative of a problem, right? Okay, it could be that that string could have been shared. Now, in this case, it's not really adding up to a hill of beans, so probably, it's 2K, right? Well, okay, 3K. So it's not maybe really worth running this down and, making some architectural change to WinForms to save like a couple K, okay? On the other hand, you may find that you're getting massive duplication of strings, or very large strings that are being very durable, okay? And this is a great way to eyeball what's going on. You can see some of the other ones, right, are the permission set XML strings that are around. Now, as it happens, I think both of those are actually dead. Again, so if we did a GC collect, we could watch them go away, dump the heap again, and you'd see, aha, it's gone. Because we needed to parse those permission sets, and then once we're done parsing that string, we don't need it anymore. So what we're seeing here is some leftover from startup. But still, interesting to see what was on the heap and what caused the collector to do work to get this far. It's very helpful when you're doing a forensic analysis to see what's up with memory. So again, look at strings because they're frequently space hogs. Dump heap dash strings is a great way to get a summary of what the heck those strings are. All right. Well, suppose now we find something on the heap and we see something that we didn't expect to see. Okay? Like for instance, in this example, I'm saying, well, let's look at menu items. I just did a dump, okay, and I was looking at the statistics, and if it turned out that there were a lot more menu items on the heap than I expected to see, right? Then I might think, well, these were supposed to be dead. I'm not supposed to have menu items around at this point. I mean, maybe there's 50 menu items, and there's only supposed to be 2, okay? Well, this is a well-behaved application, so really there only are 2, but here they are, okay? I went dump heap dash type system.windows.forms.menu item, and I got the address of the 2 objects that are menu items. There they are on the left. See, it's my little buddy, AB6170 and AB61FO. I'm very good friends with those 2. Have them over for dinner. And those 2 guys are being held alive by somebody, right? Somebody's keeping them alive. Now, in this particular case, they're supposed to be alive. But if you were looking at lots more of them, you might find that there's, lots that aren't supposed to be alive. So you can pick some of those addresses and see what's going on, right? You can say, okay, well, tell me about that first one, AB6170, and then you can use the exclamation point GC root command. GC root will give you a dump of all the various pointers you must follow that are keeping that guy alive. So in this case, if we look at the EBX register on the processor, we'll find that is pointing to the thread context for the application, which is in turn pointing to the form, which is in turn pointing to the menu item, which is a pretty healthy reason for a menu item to be alive. So that makes a whole lot of sense to us. If, on the other hand, this object was being leaked, right, and that link was not supposed to be there, that would be your smoking gun. Because you could say, wait a minute, that form was supposed to have released that menu item when I, dismissed it. The form's supposed to be gone. What is it doing still holding on to the menu item? So then you can go and look at your cleanup code that's associated with that form and say, aha, I forgot to release a reference. Maybe it's still registered to receive an event somewhere or otherwise connected to that permanent root, which is clearly identified here. Okay? Looking at that permanent root, you can decide what tactic you should be using to release those objects, which in turn will give you that memory back, which in turn solves your memory problems. So the beauty of this is that when you have 50, 100, or 200 lots of objects that are leaking, it'll be in your face. When you do the dump, you'll see there's 200 menu items, and there's supposed to be 2, right? So it sticks out like a sore thumb. And when you dump them, there'll be 2 items that are supposed to be alive and 198 that are supposed to be dead. So if you pick one of them at random to dump, well, you're like 0.5%. There's only a 0.5% chance that you'll pick the item that is supposed to be alive. You're 99.95% likely to pick one at random that's supposed to be dead. So it's very easy to spot the ones that are supposed to be dead, right? You could try a couple, and by just picking out a couple at random, you're very likely to find an example of a guy that isn't supposed to be alive and get the information you need to eradicate that guy. Okay, so very straightforward technique, and all of this is what, 30 seconds of work so far? Connect the debugger, type a couple commands, pick a hex address at random, type gcroot, and stare at your output. Again, what you'll see down here will be data types that you own largely near the end. At the beginning, you'll tend to see infrastructure items, right? Because usually it's something like the thread context or some system array and a global. That's the initial root. But very soon in that array, you'll start seeing data types that you're familiar with, and it'll be your application objects holders. So that'll be very helpful for you to find out how you should deregister those objects and get them reclaimed. Okay? All right. Now, the next trick is to find out, how did this thing get allocated? Sometimes, we have these objects and we're like, well, who made this thing? Which one is this? How do I find out where these objects are even coming from? Right? This is a great time to use our other tool, CLR Profiler. Again, readily downloadable. Now, in this case, what I've done is I ran CLR Profiler actually on itself. So I ran 2 copies of CLR Profiler. I started one and used the first one to profile the second one. And I saved the resulting profile log as a text file. It writes it out as a text file if you want. And I've got a little tool called logdump, which I posted recently on my blog in source form. It's, very small. You can compile it in 10 seconds flat from the source. Well, less than 10 seconds. And it will analyze a CLR profile log and give you a textual summary. Now, there's 2 reasons why I'm showing this. The first is because sometimes CLR profiler logs for real-world examples are massive. I've had customers come to me with 1 gigabyte, CLR profiler logs. And so the idea of like opening that up in a UI and browsing through it is kind of, it'll take like minutes for it to open up and then, to click through and find the biggest things. It's just pretty sluggish. So the logdump tool is convenient for that because in a comparatively small number of seconds, it'll grind through even a massive log file and go and give you the statistical winners for instant analysis. And then you can, it's just plain text, so you can mail it to your friends or, post it up on your whiteboard and cross off the ones as you've investigated them or whatever you want. It's also a great place to go for an initial summary because even if your log file is smaller, it can take you a while to get to the hotspots in CLR Profiler. So if you can get some hints as to what you should look at, that will save you some steps, and then you can go and interactively browse the ones that are interesting and see what else you might want to learn. Okay? So I don't want to downplay the interactive features of CLR Profiler because I love them, but it is also nice to just have something that's sort of one-stop shopping. I run logdump and I get this result. Okay, so the first part of the result that you get is the top 10 allocated types. Okay? This is total allocations, and we can see right here, okay, that the number 1 allocated type, amazingly enough, is system.string. okay, of which there were about 1,000 instances for 50K. And it goes down from there, okay? Now, this is a great way to see kind of what are my likely problems, you know? Is that too many strings being allocated? Is that in line with my expectation for the startup? In this case, it pretty much is, because there's not really any problem with the CLR profiler startup sequence. But in your case, you might find that something is sticking up like a sore thumb, right? A good way to look at these numbers is to think about how big was the volume of your input. You know, if you were, say you were writing a parser and it was supposed to read 10,000 lines, okay? If you looked at the total number of strings, you'd want it to be sort of proportional to the 10,000 lines that was read. And maybe those 10,000 lines get broken into 4 pieces, so you might think, okay, I need 1 string for the line initially, plus 1 for each of the 4 pieces, so that should be about 50,000 strings, plus or minus some temporaries for startup, so okay, say 60,000, great. Well, if you were seeing 600,000, okay, well, that would be bad, right? Because now you're thinking, oh, hey, something's gone very wrong. I'm supposed to only have 5 pieces for every line, and I'm seeing like 100 pieces for every line. That's very bad. So then you can go and it will give you some guidance as to where you might start looking for that memory problem. Again, the goal with using these kinds of tools in this sort of coarse way is to help steer you in the direction that's most likely to yield fruit, because there's many different kinds of memory problems. And if you start investigating everything in depth all at once, you will soon, you know, you could waste mountains of time looking at code and code wasn't the problem at all, or you could, you know, be looking at the wrong data type. So use these, you know, sort of high-level tools to hone in on where the problem is really going to be for you. So this particular summary is saying, no, nothing terribly remarkable, some use of reflection, some use of strings, you know, pretty healthy startup. But let's say we wanted to drill in on that. Okay, who ordered the hash entry? The dumper is capable, in fact, does by default, of describing what stack did the allocations for which objects. And in fact, it orders the call stacks by their pigginess, okay? Now, in this particular example, I've shown call stack number 6 of 10. And the reason I showed number 6 is for no particular reason other than it fit well on the slide. I needed one that was about 7 lines long, or, you know, about this long. So I picked number 6. The other ones were, you know, equally interesting and responsible for maybe even more memory. But this shows you kind of the sort of output that you can expect to get, okay? CLR Profiler knows this information as well, and you can get this out of the GUI. But a lot of times, using log dump, okay, just looking at the first 10 stacks or the first 20 stacks, you can pass in a little parameter to indicate the number of stacks you want. Just looking at those first few stacks is a great way to quickly get an idea of where your memory is coming from. I have yet to run this tool on a production application and look at the top 20 stacks and not see at least one thing that needed fixing immediately. Okay, this is just a great little thing, and it's pretty much the same as if you went into the interactive UI and you kept saying, okay, show me the biggest subgraph, and show me the biggest, 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 until you got all the way to the bottom, and then you had the whole stack that was responsible for the allocations. So what you're seeing here is that main called the form1 constructor, which called the initialize component, which called the shortcut property setter, which called isDefined on object, which called getHashEntry, which in turn did all these allocations. Okay? Now, that's pretty powerful information. And that was just stack number 6. Right? You know, if you were looking for problems, of course, it's more interesting to find problems in stacks that are further up on the list. But this is just coming right out of the tool with basically no sort of, you know, no direct need for involvement on your part at all. You're going to go and look at it, and you can analyze it, and you get symbols, and then you can mail the text to your friends. Right? Takes just a few seconds to do this. Okay, once you've got the lay of the land, once you understand what you need to do and where your big types are coming from, that's when it's time to start getting interactive. That's when it's time to start thinking, okay, well, you know, how can I find out more about these strings? I can use CLR Profiler's features, for instance, to cull particular call trees and find out who's responsible for the different allocations. Maybe I can find out more about context. Maybe I can instrument my program and see, you know, what the nature of the transactions that were going on were during those allocations, and enrich this information with logging or what have you. There's many different views available with our existing tools. The summaries are a great guide, though, and they're also a great way to validate experiments fairly quickly. One of the most important things you can learn about doing performance work generally is that it's important to make lots of theories and not sort of throw away your theories, before you've had a chance to validate them. The trick is to try a variety of different things, and then get in there and quickly determine what's working for you and what's not working for you. So I'm a big fan of doing quick experiments, right, where I'll say, oh, well, if this is the string problem, if I delete a few lines of code here, that should make it go away. I can try that. Even if that breaks my program, I can still conduct the experiments and quickly determine that I'm on the right track. So you want to spend very little time on the losing techniques and hone in on the winners right away. Getting focused on the winners and increasingly focusing on the winners is definitely the way to do these analyses. I'd like to tell my friends it's like the secret of good photography, right? The trick to good photography is to take lots of pictures and don't show anyone the bad ones, right? I go to Alaska, I took 5,000 pictures, okay? I showed my friends 50. They think I'm a stud, right? Okay, well, I didn't see the 4,950 crappy pictures. Okay, and performance work is very much the same way. Don't restrict yourself too much up front, but quickly determine what is likely to lead to fruit, okay? So you want to quickly identify, am I looking at a code problem? What am I seeing in VA dump? Is it my modules? Is it the CLR's modules? Who's causing that code to be brought in? Do I have dependency problems? Do I have management problems? Once you've come this far, you can then start looking at further information in the CLR profiler. You can look at performance counters, looking at your object lifetime and how things are getting promoted into the various different generations. Look to see if you have lifetime issues, making sure that things are dying in the right places. In CLR Profiler now, in the beta versions for Whitby, we've added new functionality that lets you track where objects are living and dying, so you can see what objects are expensive to collect and what objects are not expensive to collect. Not shown here is the views that indicate what objects are being finalized and what their origin was, what objects died in generation 2 and what their origin was. That kind of information is invaluable to you. Okay? And that's pretty much all I have in the way of a presentation. I promise to include links to my blog so that you can find out how to get all these tools yourself. And I'll be having another posting here. And I want to open up the floor for some questions. I left a good bit of time so I could take a few questions this time. I was running like right to the wire yesterday. So if you feel like you would like to ask, I encourage you to come and take the mic. And if you don't have questions, I'd like to encourage you to go and fill out the evaluations for this session and all the other sessions, in fact, right? And I think there's an opportunity to win prizes. But please, don't be shy. Come and take the microphone, and let's make this a little bit interactive and, have a little bit of fun. Thanks very much. Questions? Anyone?
For automatic testing, is there a tool that can detect if your modules need rebasing?
Is there a tool that can detect if your modules need rebasing? Well, for me, I just use VA dump because VA dump, it's just pretty much right in your face. If you see everything has gone private, there it is. It's been relocated. But most debuggers and even WinDBG will report the base address that the thing requested and also the address that it got loaded at. And so if they're different, guess what? It got relocated. But usually VA dump is enough. So I don't, I never find that I really have to look very hard to find the relocated ones. They leave a big wide swath.
Thanks.
More questions?
Yes. I missed the first 10 minutes of your presentation. Where do I get VA dump?
All of the tools, and the location of all of the tools is available on my blog. So if you just saw that last slide there, I actually have postings on this, and I'll include links. Later today, I'll make a special posting for kind of covering the material that I covered today, and I'll include links to all of those. But they're available for download, in the appropriate section of Microsoft.com. But you don't want to browse for it. You can find it just by searching for VA dump on Microsoft.com, but I'll give you the direct link. Just go to my blog, blogs.msdn.com/RicoM.
Also, is there
Sure.
anything in Visual Studio for any sort of profiling or that sort of thing?
VSTS includes a lot of the best-of-breed features from CLR Profiler. You can think of CLR Profiler as kind of our testing bed for a lot of this stuff, and we've thrown in the kitchen sink, right? Some of it is pretty darn usable and pretty useful to many different people. Others of it is kind of, esoteric and maybe wasn't such a good idea. Or it works well for us, but, I don't know that we want to inflict it on the rest of the world. So the VSTS team, in their profiler, they took the best ideas we had and with the time they had available, and incorporated those into their profilers. So they have a lot of the views that I showed you, they have available as well. But that wouldn't have been very MacGyver of me to show the tools. So I'm trying to give a very sort of low-level way you can do this on any machine with just any kind of resource. It's terribly handy to be able to go into production if you need to, and in 5 minutes flat, you can install this stuff and have a really good idea what the likely sources of problems are and have valuable data to bring back to the development team, even though you might not be able to install Visual Studio right in situ on that box. All this stuff is very non-invasive, so that's why I'm kind of highlighting that today. More questions? We have a few more minutes.
Hello, here.
I'm sorry, I can't see you because of the light.
Oh, okay. You cannot see.
Yeah, but I can hear you.
Okay, question. NGen 2.0 supposed to help us a lot with speeding up of cold start.
Yes.
We talked yesterday about that. I want to know what's the fastest way to see if NGen is working for a particular application, because I think the biggest problem is when native assembly cache assemblies get loaded with non-native assemblies, and it basically bogs the memory and I/O and everything.
Okay, there's two things that you can use that will help you on this quest. The simplest is, again, if you look at the VA dump output, you'll see whether or not the native images were selected, because you can see the .ni's in the file name. So if you're seeing the .ni's and you're seeing that they have nice private page numbers, then you're in good shape. You got the native images and they were loaded. If you want to know why they weren't loaded, that can be more complicated, but we do have tools to diagnose that. There's a log that can be optionally created that sort of documents the reasons for choosing or not choosing a particular assembly and why we went a particular place and where we looked and what decisions we made. So the code name for that loader is Fusion, and there's a viewer for the log that it can create that you can select. And I think that's in the SDK tools.
Yes, actually, Fusion is available on any machine. But I was thinking maybe as a performance counter, which can tell us how many assemblies gets loaded. Like, let's say there are twice as much because we get both, native and non-native.
I don't know that.
But I didn't find anything like that.
No, I don't think there's a performance counter for it. But again, VA dump really tells you everything you need to know about what happened after the fact. The reason to go to something like the log viewer is if you want to know why, right? If you think the native image was there and it's not being selected, it's sometimes useful to know, well, why didn't we pick it? Why couldn't we use it? Because usually there's a reason. Maybe it's stale, or maybe it's, whatever the reason might be, it'll be in that log file. But in terms of seeing what got loaded, VA dump tells the tale. So that's fairly straightforward. Or also the debugger's output. When you connect a debugger, you can watch the loaded assemblies, and you'll see what got dragged in, because there's debugger notifications for all of them, and they go in the trace. Regardless, pretty much all the debuggers offer that functionality. So you'll see the full paths, and you'll see where they're coming from, and you can validate that you're getting exactly what you want and nothing more. Further questions?
Yeah, over the last couple of years, I've been to quite a few different PDC sessions that sort of offer mixed messages in regard to whether or not to NGen your code.
Yes.
And whether you choose to NGen or not affects your coding strategies.
Yes.
To optimize the JIT compiler. So as a developer, I could spend a lot of time organizing my code to make the JIT compiler more and more efficient, and then at the end of the day, go, well, heck with it, I'll just NGen it. So I'm wondering if there's if the stories may be changed. Should we take a harder look at NGen? What should we do?
Definitely, the story has changed. We made significant investments in WIDBE in NGen. So in many cases where NGen was not providing a benefit in the 1.1 product, you'll find that it is providing a benefit in the 2.0 product. Now, I won't give you blanket advice like always NGen, because there are cases where it's just not going to help that much. ASPX scenarios, for instance, a lot of times, NGen is not going to make that difference unless you have significant libraries involved, and they can be NGen'd. But generally speaking, you'll find on the client side that NGen is the preferred story for maximizing the memory usage. That is minimizing the impact of your application on the system in question. And we've made significant improvements, right? The private pages are down from 50% of the image to 10% of the image. In many cases, the overall working set for the same scenario was cut by as much as 50%. So big, big improvements in terms of layout. And we can do some nice things in engine time that we can't do if we're jitting. Now, contrary-wise, the jitter is not bad, and so a little bit of jitting is not a disaster. And in many cases, a blend is the right approach because it helps you with serviceability and maintainability. In both cases, it's the same underlying compiler, right? We use the JIT compiler as the thing that does cogen for us when we do engine. But we have more, and we're engineering the whole thing, and so we have some additional information available, and we can consolidate things a little bit better, and we have an opportunity to give you shared data. So if you're targeting low-end machines, if you want it to run on your mom's 128 meg machine, NGen is going to be a big part of the answer for you. So I really encourage you to look at it in very strong terms. But by no means do I give blanket advice like always engine. I never give blanket advice. Try it out and see if it's helping you, and then make the best choice for your customer.
Thank you.
I think I'm pretty much out of time, so I think I could take one more question, and then I got to wrap it up.
Do you need to clean up after the NGen stuff when next V2 comes down? Or does that cleanup happen automatically? I mean, it's stored in the cache.
Yeah, that's right. We manage the cache, so you don't need to worry about
Okay.
you don't need to worry about that kind of stuff.
Okay.
Yeah. Okay. Thank you very much for coming, and please fill out the evaluations and be gentle. Thank you.